Hi, my name is Jay Harris, and I'm here today to show you how you install the Alston drag racing electrical kit in a naturally aspirated car. We're going to take you through the process step by step, from wiring power from the battery, wiring your switches, and wiring your outputs, and really show you everything you need to install this kit. Here on the table in front of me are all the basic building blocks you're going to need to wire the car. The first thing right here is a block of what we call mega fuses, and these protect the primary feeds from the battery. This is what we call the power cell, and think about the power cell as the fuse and relay box. So all of the switching actually happens here in the power cell. This power cell gets its commands from this guy over here, which is called the master cell. And the master cell takes in all the switches. So everything from your line lock switch to your trans brake, also from our panel of switches. This is also the key to the diagnostics of the system, is the screen here on this master cell. Lastly included in the kit is this panel of switches. Very simple to read, very easy to use, and very easy to install and wire into your system. So those are the basic building blocks of the system to wire the car. We're now going to take you through that process step by step. When guys have problems with wiring their cars, almost 90% of those problems are related to bad grounds. That's why when you wire your car, you have to make sure that you've got the best connection from your switched thing back to the negative terminal of the battery. And if you're using the chassis, you have to make sure that you've got a great solid welded stud with no paint, no powder coat, and no corrosion. And so in this case, we've got welded studs throughout the car that we've gone at with a wire brush. Even though we have this really pretty powder coat on the chassis, we've gone at this with a wire brush to make sure we've got a good, reliable metal-to-metal connection from our ground wires to the chassis, and then from the chassis back to the negative terminal of the battery. So the next step of the process is really understanding where your switches are and where all the switched things are. And by a switch thing, I mean your fuel pump, your water pump, your line lock, your trans brake, your starter solenoid, your coil. Because what you want to do is you want to put the cells in the car closest to your switches, that's where you want to put the master cell, and put your power cell closest to the switched things you're controlling. The whole goal is put the cells where you need them, reduce the amount of wire. Less wire means less weight. So we're going to walk around the car right now, figure out where all the switched things are, and then make some decisions about where we want to mount things. So we've walked around the car, we've looked at where things are, and this location right here is really the best. It's very close to all the switch things that are around the engine. It's also really close to our MSD. So we're going to put the master cell and the power cell right here. We've already fabbed up this bracket. It's going to keep the runs of wire short. It's also going to make the cells really accessible for diagnostics. And if we ever need to get to the fuses, this is a great location right here. So now that we have the cells located, we have to get these two cells talking to each other. Again, this is the master cell. Your switches are going to connect here. This is the power cell, and your outputs connect here. In your kit, we give you what's called a CAN cable, and CAN stands for Controller Area Network, and that's what lets the two of these cells talk to each other. Now, the cable that we're going to give you is probably longer than you need, so you can cut that to whatever length you need, splice it together, and it's really designed to let you have the flexibility about where you're going to put these cells in the car. So we've got this cable dressed up the length we want. I'm going to plug this guy in like that. I'm going to plug it in like that, and what we've done now is we've connected these two cells together. Okay, one of the biggest advantages of the kit that we have are the switches. And these are the switches that you're really using to control the car. To turn on your ignition, to crank the motor, to turn on your fuel pump, to turn on your water pump. They're very simple switches, they're very reliable, and they come down to just one cable. So what we've done is we've fabbed some mounts, actually on the roll cage here, and we're just fitting that panel of switches into the car. Included with the kit are the switches here, and also this aluminum enclosure that you could use really any way to mount the switches in the car. So we're going to get this spotted, we're going to bolt this thing in, and our switches are largely done. Okay, so now we're going to start connecting the wires to your switches and the wires to your outputs in the car. And included in your kit is what we call the configuration sheet. And this is really important because this is your map to wire the car. What the configuration sheet does, it lays out all the pre-configured functions in the car. It tells you what color input to the master cell, It also tells you what color the wire is for the output coming from the power cell. So for example, here's your starter. It's one of the pre-configured functions in the system. That starter, if you run across, is the light blue wire on the power cell. So you're going to connect the light blue wire from the harness on the power cell to the starter terminal on the starter solenoid. That's simple. You do everything line by line, color by color. But again, this document right here is your roadmap to wire the car. Okay, now that we have primary power routed from the battery, we need to get power to our fuse holders, and also then we need to get power to the actual power cell. And that's what this harness is. Now in your kit, this is a much longer run of wire. For simplicity, we've actually cut this to length and actually formed it the way we want to run the car. But these connectors right here come pre-terminated as part of the kit. And on the other end, you're going to cut that to length and you're going to crimp on these ring terminals. Again, these ring terminals are included with the kit. So once we get this piece of cable routed the way we want, we get these terminals routed on, we're actually going to take that and connect that here to this side of the fuse holder. All the hardware is included. The primary power from the battery is going to go to one of these studs here, and then each of these fuses here protect these wires that provide power to the power cell. So if one of those wires were to break and get shorted to ground, this fuse will open up and protect it. So now that we've got that done, we're going to plug this into the power cell and dress this part of the harness up. Okay, next I want to talk about wiring in your switches. For the most part, all the switches in the car are on the overhead console. But there are some switches that are external. For example, the line lock switch, the trans brake switch, if you have a neutral safety switch. And this is the master cell harness. Again, we give you more wire than you're going to need. In most cases, guys are throwing away the extra wire. We give you extra length, so you have flexibility in routing it. We also give you some more inputs that you may not need. It's very easy to take the unused wires out of that connector. But so in this harness, we have the wire colors that match the functions on the configuration sheet we talked about earlier in the video. And there's also a bunch of black wires. Those black wires are grounds. All of the switches in the car work by closing the input to ground. So for example, the line lock switch or the trans brake switch. One of these master cell input wires connects to one side of that switch. The other side connects to ground. We're going to go to the car right now and I'll show you what we mean. So here I want to show you how to wire in a switch. And again, this is one of the things that is so easy with our system. We talked before in the video about the inputs to the master cell. Again, in this case, there's the input for the line lock switch here, and then I'm also going to take one of the ground wires right here. I'm going to take those two inputs, and I'm going to come over here to this pigtail harness that came with the Hurst shifter for the line lock, and I'm going to put the connector on here that's going to connect the master cell input to the red wire, and then the ground to the master cell is going to go to the black. So that's as easy as it is to go up and connect your inputs from the master cell to the switched functions in the car. So the switch panel that's above the driver that's controlling all the major functions in the car, that connects back to our master cell through this simple little yellow cable right here. And included with the kit is this cable. Again, you can cut this cable to length as you need it and adjust the length so it fits your car perfectly. And then that connector screws right here onto this socket on the master cell. And this is a sealed connector, so you don't have to worry about water or dust or dirt getting in there, because all the connectors on the system here are sealed against moisture and immersion and water. Okay, now it's time to actually start wiring the outputs into the power cell. We include the harnesses in the kit to do that, and those switch things are things like your starter solenoid and your trans brake and your line lock and your water pump. All the switch things you're going to turn on and off in the car. In the kit, we give you this harness. Actually, there's two, an A and a B, and all the colors on here match that configuration sheet we talked about earlier in the kit. So we're going to plug the power cell harnesses into the power cells, run the wires in the car, and start connecting those to our outputs. Now, another very important thing here is in this harness is actually a black wire. We talked earlier about the importance of grounds. There's two ground wires on the power cell, one in each harness. So cut that to length. We include this ring terminal in the kit, put that terminal in there, and connect it to a stud that's got a good metal-to-metal connection to ground. So let's go see what happens in the car. Okay, let's start connecting outputs to the power cell. So we've run that harness from the power cell all the way up here to our fuel pump. I've looked at my configuration sheet, and the fuel pump is actually the dark green wire, so I've pulled that up here. And what I'm going to do right now is I'm going to connect this dark green wire to the lead on the fuel pump. So you've got a couple of different options. We're actually going to put connectors on here so the two of these plug together, so if we need to service the pump, we can take it out easily. That's really as simple as it is. Output wire from the power cell connects to the switched load. In this case, it's the fuel pump. And on the other side of that fuel pump, we're going to take the black wire that comes with the pump, we're going to put a ring terminal on that, and we're going to connect that to ground. And again, remember what we said before about grounds, you have to have a good metal-to-metal connection for the best reliable and the best performing system. Okay, it's time to connect more loads. Now we're going to do the line lock solenoid. So again, I've looked at my configuration sheet, it's told me the wire color, and I'm actually here at the line lock solenoid. We're going to run this wire through the car, dress it to length, and I'm just going to connect with a simple connector. I'm going to connect the wire for the line lock solenoid to the output from the power cell. And just like we said before, I'm going to put a ring terminal here on the ground off the line lock and get a good metal-to-metal connection to the chassis, just so we have the most reliable performance of the line lock. And again, the way this is going to work is when you actually are holding the line lock button down in the car, that's triggering the input to the master cell. The master cell tells the power cell, turn that output on, or when you let go of the button, turn the output off. So again, it's really that simple. Okay, let's connect the starter solenoid in. Again, I've gone back to my configuration sheet, which is my roadmap, and it tells me it's the light blue wire off that power cell is what actually is going to connect to the starter solenoid. And in this case, it's actually a 1/4 inch spade terminal here. Again, I've got a real good set of snap-on crimp tools. I'm going to go off and actually strip this wire back just a little bit. And now that I've got that done, again, I've got another really good set of crimp tools right here. I'm going to crimp on the spade connector right here. Whenever you're crimping, give it a good tug to make sure you've got a good reliable crimp right there. Okay, once I have that done, I'm just going to real simply plug that onto there, and now I've got a good reliable connection from the power cell to the starter. Okay, let's talk about getting power from the battery to the starter. Now, we don't give this to you in the kit, so you've got to source this yourself because, again, every car is a little different, locations are different. But I want to talk about the importance of picking the right size of cable to go from your battery to the starter. Again, this is not a place to get cheap, and this is not a place to go off and look to save a couple of pounds. When you're cranking your engine, and again, especially if it's a big, high compression engine, you'd be drawing more than 3,000 amps instantaneously to crank that engine. And then steady state, when that's running, that starter could be drawing 150 to maybe 300 amps. So you've got to make sure you've got a good sized cable to go off and go from the battery to the starter. So what I have here is actually welding cable. This is nice for a couple reasons. First off, it's high temperature wire and it's very flexible, which makes routing it through the car very easy. You can get this from a handful of different places. If you need help sourcing it, call the Alston tech support guys, they can help you. But we've actually picked a single aught, so 1/0 gauge wire. That's plenty big to go off and draw the current we need going from the battery to the starter, but I wouldn't go any smaller than that. So again, don't go cheap on battery cable, and also remember that when you're going from the battery ground to the chassis, the pipe going out, so that red wire going to the front of the car, has to be the same size as the pipe coming back in, which is the ground, the black wire from the chassis to the negative terminal. So make sure that you've sized both your positive cable and your negative cable correctly. Okay, we've talked before about running power from the battery to the front of the car to get to the starter. But I want to show you what we've actually done here. We've got two batteries in parallel, so two 12-volt batteries, which means that we have to tie both the batteries to ground and both the batteries to that primary feed, that single aught piece of cable going from these batteries all the way to the front of the car. Now, we talked about this earlier in the video, but this is not a place to get cheap on wire gauge, and also don't get cheap on the tools that you use to crimp these together. You can really source these battery cables and battery clamps anywhere you need them. And if you need help finding those, give the Alston guys a call. They can point you in the direction to find the terminals and the battery clamps to really properly wire the battery into the rest of your car. So we have the two batteries wired in parallel to the disconnect switch. And again, that's an NHRA, and most of the sanctioning bodies mandate a disconnect switch. So when we close that switch, you've got power to the car, but when you open it, the car is completely dead. So from the battery to that switch, through that single aught piece of cable going all the way to the starter, And then off the starter is where we're tapping off to feed the power cell, and that really is what powers everything in the car. So let's go take a look up front, and we'll show you how we're connecting power into the power cells. Okay, so we've got the battery connected in. We've got that 1-aught piece of red power coming from the back of the car. It's going directly here to the starter, and then we're tapping off that with a short piece of 4-gauge that's included in the kit, and that's going to the fuses, these 2 mega fuses we've talked about before here in the car. And those are protecting the power feeds that actually power the power cell. So primary power to that block of fuses, and those fuses are protecting the actual power that's driving everything in the car. So now let's go take a look at how we get power into ISIS to make all this stuff happen. Okay, earlier in the video we actually showed you the 2 8-gauge wires that come with the kit, and that they bring primary power into the power cell. And that's the power that's going to all the switch things in the car. The lights, the fans, the pumps, the ECU, the starter solenoid. They come pre-terminated with the connector on one end. So we showed you just a second ago where they connected to the fuses. Now you're just going to take the 2 of these and plug those there into the power cell. Really simple, really straightforward. And then there's an open socket right here that you can either use for expansion, or in the kit there's a dummy plug that plugs into there to seal that up to keep the whole thing watertight. Okay, so we showed you how to wire all the switch things in the car. Those harnesses come complete in the kit with the mating connector that mates with the power cell on one end, and then the big long run of wire on the other. So you take these harnesses and the manual shows you where they go, and they literally plug right here into the power cells. Again, you'll get a good audible click to confirm that they're seated properly. And again, once they're seated, that's a sealed connection. So you've got a great watertight assembly right now. You don't have to worry about dust or dirt or spray getting into these boxes. So we've talked before about how the master cell and the power cell work. The master cell is the brain, and that takes all the inputs from your switches, whether it's the pack of switches on the roll bar or your line lock switch, your trans brake switch. That sends commands to the power cell, which actually switches the things on and off. Your fans, your pumps, your lighting, your starter solenoid. We've got to get the 2 of those boxes talking. So in your kit is what we call the CAN cable. And again, that stands for Controller Area Network, and that's really the data cable that lets the 2 of these boxes talk. So I'm going to plug this guy here into the master cell. I'm going to plug the other end of that into the power cell. And then in the kit, you get what we call a terminator resistor. It's actually got an R marked on it for resistor. And what that does is that just matches, essentially it lets the 2 boxes talk together. So I'm going to plug that terminator resistor into the unused socket. Now this cable comes longer than you're probably going to need it. So you can cut that cable and shorten it as you need it, or if you need to stretch that cable out, as long as you match wire color to wire color, you can make that as long or as short as you need for a car like this. Okay, now it's time for the moment of truth. We've wired our switches, the switch panel, and also the switches on the column into the master cell. We brought primary power in from the battery to the starter, and we brought power into the power cell here. We've connected all of our outputs, so all the switch things in the car, we've connected those to the power cell, and we've connected the CAN cable between the 2 cells. So we've got the system ready to go. We're going to put power on it, bring it up, and I want to show you what happens when you actually start the system up. So let's go off and pull the switch in the back and bring power to the system. Okay, so a couple things you'll notice when the system powers up. First up, it's going to take 3 to 4 seconds. So just give it a couple of seconds to start up. And what it's doing when the master cell boots up is it's checking everything. It's checking itself to make sure everything's okay. It's also checking the power cell to make sure the power cell's okay. So it's going off and checking itself. And then you're going to see a bunch of lights flashing. You're going to see the screen come up. There's really one important thing you need to look at, and it's actually this right here. We call this the COM light, or we call this the heartbeat. There's a heartbeat here on the master cell, and here on the power cell, there's a corresponding heartbeat there. As long as that light is blinking, it means that the cells are communicating, everybody's healthy, and everybody's happy. Now, another thing you're going to notice is that here in the corner, there's a set of lights labeled CAN high and CAN low, and those are going to blink. We occasionally get the call of a guy saying, I've got a red light blinking on my box. Actually, that's okay. They're going to blink randomly. That just means that there's communication between the master cell and the power cell. So the comm light or the heartbeat blinking is what you want to see, and you want to see these here blinking randomly. So once we've got that step done, everything's good. The master cell is healthy, the power cell is healthy. Let's actually start flipping some switches and testing things. Okay, so we've powered up the system. We know the cells are communicating. What I tell guys to do next is don't put any fuses in the power cell yet. Check all your switches. And one of the best things that you can do with the master cell is it will confirm all the switches for you. So to do that, press and hold the scroll up and select buttons on the master cell, the two buttons on the right. Press the two together for a second and let them go. And you're going to get a message that says that the master cell will display all switch input changes. So once you get that done, it makes the troubleshooting, the diagnostics on the switch side really easy. So what I suggest then is start with every switch. Your line lock switch, your trans brake switch, all the switches on here, and check to make sure that you're getting the right message on the master cell. And also check that you see the output LED on the power cell turning on. So for example, if I press and hold the line lock button, I'm going to get a message on the master cell. Check your configuration sheet. That's going to be your roadmap that tells you what input, what output that is. I should see the input on the master cell, and I should see, since there's no fuses in here, the output LED on the power cell go from dim to bright. And I'll do the same thing for the trans brake, and I'm going to do that for every switch here on the console, just to make sure all the switches are working correctly and they're wired correctly. Once that's done, let's get the fuses in there, and one by one, let's start testing the outputs. So we just checked all of our switches and all of our inputs, and they're all working correctly because we verified it here on the master cell screen. We also saw the LEDs go bright on every power cell output. Now, let's start putting fuses into the power cell and start checking those outputs one by one. Now remember, the power cell has the switching inside it. It has the relay, and it also has the fuse box. So the fuses are actually what are protecting the wires going from the power cell to all your switch things, like your pumps and your fans and your lighting. So it's a standard mini fuse, and again, we give you in the kit a collection of fuses. A lot of people ask, what size fuse should I be putting in there? There's a good table that's in the manual that tells you the size of fuse you should be using to protect the different loads in the system. But at the end of the day, that fuse is there to protect the gauge of wire, not the actual load. So you really have to pick the right size fuse that sized the smallest gauge of wire going from this power cell to ground. And again, there's a good table in the manual that will show you what you need. So again, I'm going to take these fuses, and we're going to go through these one by one. Let's get the fuse in there, turn the switch on, and make sure our things are turning on and off. So now one of the really important diagnostic tools that are built into this system is actually a way to tell whether or not your load is properly connected. For example, your lights or your pumps or your fans. And again, if you look, every output on the power cell has an LED, and that LED can do three things. It can be on, which means the output's on. It can be off, which means the output's off, or it could be dim. And if it's dim, it means the output's off, but it also means that the output's not connected correctly. So what happens is, on every output on the power cell, we leak a little bit of current. That current, if everything's connected correctly, flows through the fuse, through the wire, through the actual load, whether it's the windings of the pump or the filament of a light bulb, and goes to ground. And that LED is out. But if there's a break anywhere in that chain, let's say maybe the fuse blew, or you've got a broken wire, or maybe you've burned out a light bulb, then this LED actually glows dimly. So that's one of the really important diagnostic things here, is that if you ever see a dim light here, it means that you should check that fuse, or you should check that wire as it goes through the load to ground. And you'll watch, when I actually plug the fuse in and make the circuit, that LED right here, which is dim, is going to go from dim to off, because I just completed the circuit. So we'll get the rest of the fuse in here and start cycling loads on and off and making sure everything works. Okay, so as an example, let's go check our cooling fans and make sure they're wired correctly. In this case, we have two outputs controlling two fans. So in the previous, like we talked about in the previous segment, I'm going to take the fuse, I'm going to put the fuse there into the power cell, and when I'm doing that, I'm checking to make sure that that LED goes out, it goes dark, That means now I've got a good connection. And then now what I'm going to do is I'm going to go hit the switch on the panel above the driver's head. Make sure these lights go bright. Let's also make sure the cooling fans turn on. Once we have the cooling fans done, we're going to go with every other output on that power cell and check it step by step just to make sure everything's working correctly. Okay, so we've gone through and checked every output and everything's working correctly. The last thing we're going to do is we're going to put the covers on the cells here. And again, these covers are really the last step to make sure that everything is sealed. Again, sealed against dust, against dirt, against salt, and against whatever you'd find at the track. And also, the other thing you need to make sure of is that you have all the connectors installed in the cells. That's what seals the whole thing. So we give you all the connectors, even in the unused sockets, to close those up. So just make sure that the last step what you're doing is put the covers on, put the unused connectors in, and you're ready to go with a real solid, robust, sealed system. Okay, so we've taken you through the whole process of wiring this drag car with the Alston Racing Performance Electronic System. We showed you how to wire power in from the battery, how to place and locate the actual cells that are in the car, how to wire your switches, how to wire in the switch panel, how to wire your outputs, and really how to test the whole system and make sure everything is working correctly. We hope you enjoyed this. We hope this has helped you install and learn everything you need to know about your system. If you do have questions, reach out to the Alston Tech Support guys. They can walk you through the whole process and help you in any way you need. Thanks for watching.